to learn once again the best subject in the world, unarguably. Just last week, I got a very good review and it really gave me happiness within me, definitely did. And I'm really grateful. Now, today we are going to learn a new topic entirely. We had learned in our previous class on indices, and we're able to look at what indices entails, the law, and how to apply those laws of indices to solving equations. So today we are going to learn a topic that is related to indices and see how well we apply those laws of the new topic that we are going to learn in solving maths questions. Now, before we look at the topic for today, I want to give a very simple scenario. Let's assume something of this nature. You were given 100 naira for the first week and you were told that every week that money will be doubled. So that first 100 naira you had was being doubled the first week, meaning that you had 200. So the next week is that money would now be doubled again. So you'll be having 400. Now, after that, it's going to be doubled again. You have 800. Then after that, you double it again. You have 1,600. Now the money keep doubling like that by whoever has made that agreement with you. Now, the question I'm going to put forth to you is this: how long will it take? In how many weeks, right? Or how long will it take before you get a million naira? Do you know that if you want to start doing that calculation till you get to a million naira, it's going to be exhausting, right? That is where the topic comes in. So, this topic is more or less like a superhero to give answers to questions of such nature and even beyond that. And the topic that we have for today is logarithm. That's our topic. So we are going to look at three things. We are going to look at what logarithm is. We are going to look at the types of logarithm, and then we are going to look at laws of logarithm. These are the three things that we are going to look at for today, and that will be the end of today's class. About logarithm. Logarithm is the exponent to which a base is raised to give a certain number. So let me explain it. Now, I had something like the number here is 32. 32 can be expressed as, if you recall your index notation, 2 power 5, right? So logarithm is saying that base, when you consider that base, to what exponent, another name for exponent is power, index, to what exponent will it be raised to give you back that number? To the power 5 is this. It therefore means that what log is that answer, which in this case is 5. Now, this is how to represent it in writing. So I can write this as this: log 32 base 2 all is equal to 5. So what this is saying is 2 as the base. So what number will I raise 2 as the base to get 32? That number is 5. That's why it's this. Now look at something like this. If I had log 1000 base 10, so what number will I raise 10? To what power rather, or to what exponent, or to what index will I raise 10 to get 1000? That answer obviously is 3, because 10 to the power of 3 will give us 1000. It's as simple as that. That's what logarithm in itself entails, right? Now, having established what logarithm is, and please note this quickly: when you're writing your logarithm, be very mindful how you write it. When you put your base, you can see how it is written here, base. Put your base here, you see how it is written to indicate it's a base, right? So do not make a mistake by, and that's why sometimes some people write it this way. So you can see some people write the base in words. Why they do that is to avoid the confusion, right? Because some persons can make a mistake and write something like this. If you write this, what you had actually written is log 232, but what you had in mind was log 32 base 2. They are not the same. So this is log 32 base 2, this is log 232. So indicate as your base and indicate which is your log. Now, having said all of this, we're now going to look at the next thing, which is types of. There are basically two types of logarithm. We have the common logarithm. The common logarithm means it has a base of 10, so something of this nature. Common logarithm. Common logarithm has a base of 10. Now, every common logarithm can be written without the base. Why? Because it's a common logarithm. So I can just write it like this: log 100. For the fact that I did not put the base, it means it has a base of 10, right? That is that. Then we have the next one, which is second type of logarithm is a natural logarithm. Now we're not going to spend much of our time on it, right? Why? Because it's not really a thing that we are going to study at this level. Now the natural logarithm majorly makes use of base e, yeah, the alphabet e, base e, and its value is 2.718. That is it. Sometimes logarithm also can be written this way. This is ln, that's ln x. That's how it can be written in some cases. So indicating it's a natural logarithm as the case may be. So having established all of this, now we can now look at the laws of logarithm. Addition law. Yes, that's the first law that we have, the addition law. So we had something like this. So if I had log a base x plus log b base x, all of this is going to be equal to log a times b base x. That's the first law, addition law. So when you are having addition, you are multiplying them. If you recall our indices, multiplication law, when we have addition and multiplication of their bases, we added their powers. So here now, when we're having addition, what do? We multiply, because note their bases also must be the same. Now the second law, which is just the opposite of this, is called the subtraction law. Now, in the subtraction law, what do? The same thing of this nature. So I had log a base x minus log b base x. Simple. If in this case I multiply, therefore here I will divide a over b. These are the fundamental laws on logarithm, right? The addition and the subtraction. Let's look at other laws. Now, number 3, power law. In the case of the power law, we had something like log x to the power of n base a. If you have this now becomes n log x base a. Remember also that I had said in the previous class that when you see alphabet, don't let it get you confused. So those alphabets actually represent numbers. So if I'm using x, a, n, just know they represent what? Numbers. So in the case of the power law, what it tells you that the power comes just behind the log. It's as simple as that, right? That's just it. That's called the identity law. What does the identity law mean? When you say identity law is in the case of something being equal or something having a lot of similarities. Yeah, having a lot of similarities. So identity, maybe you had something like log a base a. Since they are the same, identity therefore means my answer is 1. So every identity law gives you 1. The fifth law says the log of 1. Imagine something like this. Log, let's say log 1 base a here. Log 1 base a. Remember that in the definition of logarithm, it says that the exponent to which that base is raised is what gives you the log, right? Exponent, when we say exponent, remember we're talking about the power. That's the exponent. So if I had a, we already said this alphabet represent numbers. So this a now, let's say this a was 5. So what power will I raise 5 to get 1? Remember your 0 index, power 0. For 5 to raise to the power of 0, it's 1. It therefore means that this will become what? 0. So log of 1 is 0. So when you have a log of 1 and a base like this, then your answer is what? 0. Then the last one is what is called change of base. That's the last law we are going to be looking at, change of base. So in the case of change of base, it's when we talked about the types of log, we said there's what is called a common log, which means it has a base of 10. And your calculator also is programmed to solve questions that has a base of 10. Now, what if it does not have a base of 10 and I need to change the base? Maybe for instance, now I had log a base x and I need to solve this type of question. How do I change it? So this now becomes log a. Let's say the new base I want to put is base y. All over here becomes log x base y. So log a base y all over log x. That's your base here, base y also. So the base has entirely changed from x to y, a different base entirely. Now, Having said all of this, I want to give us a simple question that would be something for you to ponder on, and from there we are going to continue in our next class. Let us assume we said log of 1 is 0. So, and we also talked about the identity law. Now, if I had log 1 base 1, log 1 base 1, what would the answer be? Would the answer actually be 1? That is when you talked about the identity law. Or would the answer actually be 0? Because it is a log of 1. We are going to continue from that in our next class. So we have been able to look at what logarithm is. We have been able to look at the types of logarithm, and we also have been able to look at the laws of logarithm. Now, having considered all of these things, I want to beg you that in our next class we are going to solve questions that will help us look at how to apply these laws that we have looked at thus far. So please and please go back and study these things. And also, if you have questions, you have confusion, you need more clarity, you can put it on the comment section, or you reach out to me personally, and I assure you I will definitely attend to you. Thank you. Do have a lovely day, and hope to see you tomorrow by God wills. Bye.